So this first activity, screens 1 through 8, is intended to be reviewed from Chapter 3. So hopefully as we work through the problems, much of what I'm talking about will look familiar to you. So the activity is called Match by Parabola, and we're trying to match the parabola that goes through a set of points. So for example, in this particular problem here, we are given a parabola with 3 points, the bottom point being the vertex. You're supposed to try to plot. So please keep in mind that when you're doing this, it's always y is equal to some number, and it's x minus some number squared plus some number. So it always takes on this form. So the vertex is at 0, 0. So the h value is 0. And the k value is also 0. And we've talked about if you go over 1, you're supposed to go up 1, and that's the a value, and the a value in this problem is 1. The zeros are not necessary, so we could always remove the x minus 0 and just make it simply x, and the plus 0 doesn't change anything, so we could remove that as well. If I multiply anything by 1, it's going to be that answer. So this could be the final answer, y is equal to x squared, which is actually what they ask you to type here. So the reason why I went through that is because in the next problem, they're asking you to write the parabolas for these different shapes, and basically you're sliding the parabola up and down, or left and right. The equation all take on the same form. So just keep that in mind. This is going back to what we talked about in chapter 3. So they're all going to kind of look like this. Again, we are going right 1 up 1, right 1 up 1, right 1 up 1, and right 1 up 1. So the a value in all of them are 1. So I'm going to go ahead and just copy the same problem down for our equation down for all of them. And we're going to start with the blue. Now with the blue, the vertex is at 0, 3. So that means this question mark is 0, and this question mark here is 3. Because again, that's the h and the k. And again, if you're checking it, you can always say, check my answer, see if it works, and you'll notice that the blue, the equation I've written here does work, but the other ones are not completed yet. For the green, we're looking at a vertex of 4, 0, so that means the h value is 4. Oops. And the k value is 0. For the orange, we're at 0, negative 3. So this number here is 0. And here we have negative 3. And the last one, we're at negative 4, 0. So it's x minus negative 4. And plus 0. Anytime we have a double negative, we can also replace that with an addition problem. So it could become x plus 4. And if you check them, they all work. And screen here, the question raised is, Eric thinks the equation x minus 3 quantity squared will match the blue graph. Jenny thinks it's the red graph, who's correct. So again, it's always x minus the h. And the h value here is positive 3, which means the graph is being shifted 3 to the right. So that means Jenny would be the correct person, because the h value is 3, which means the graph is shifting 3 to the right. In problem 5, it's really very similar to the previous problem. The big challenge here is that a value is no longer 1. So for this problem here, we go 1 over, and it's supposed to go up 1, but actually it's going up 3. So that's the reason why the a value in this problem is 3. So for the blue graph, we're going to go 1, 2, 3, 4, 5 to the right, and it's going up 5. So if I go 5 to the right, the answer actually is supposed to go up 25, because 5 squared is 25. So for example, if I would just simply put in y equals x squared, for example, and ask to graph it, you'll notice that the graph itself is steeper than this graph. So this graph is wider because we're looking at a fraction. So if I go over 5, it's supposed to go up 25. I am only going up 5 of that. So it's kind of like having 25 pieces of candy. That's the complete set, and you got 5 of the 25 pieces of candy. So the A value here would be 5 of the 25 pieces of candy. So 5 over 25 would also could simplify to 1/5. And again, the A value is the right one since it goes through those 2 blue points. For the green graph, again, starts off as y equals x squared. And again, we're always using 0, 0 here, the origin, so that's why I'm not worried about the x minus h in parentheses, because the h value and the k value are 0 for all of these. So for the green graph, I'm going 2 to the left, which means I should go down 4, which is correct, because negative 2 squared is 4. If I go to the right, and then I should go also down, the answer should also be 4. So the answers I'm looking for are actually correct. I'm getting 4 and 4, which is what we're supposed to get. But the graph is going downward, so that means the A value is negative 1. For the orange graph, I go 1 to the right, and it should go either up 1 for positive 1 for the A, or down 1, but it's going down 2. So that means the A value in this problem is going to be negative 2, because the graph's going down 2 when you go shift 1 to the right instead of just down 1 for negative 1. Now for the last one, we're going to look at, again, y is equal to x squared, and I'm going 1, 2, 3 to the right, so it means it's supposed to go down 9. It's only going down 1.5. So what we could do is think about how, if I want to go down 9, but it's only going down 1.5, the question would be, like the problem up here, we're doing 5 out of 25. Here we're doing 1.5 out of 9. So if I count up by 1.5s, can I actually get to 9? If the answer is yes, how many 1.5s does it take? So 1.5 and 1.5 makes 3, and then that's 2 1.5s. And then if I do another 2 1.5s, that would make another 3, which is 6. If I do another pair of 1.5s, that would be another 3, which makes 9. So 6 1.5s will get me to 9. And we're only going down 1 of the 6 1.5s. So that means the fraction is 1/6. And we are going down, so that means it's going to have to be negative. With the graph to flip over, so it has reflection. And you'll see that the purple graph is not correct. So when you're counting your left and right, expect the answers to be perfect squares. So over 1, up 1, down 1 is negative 1. Over 2, up 4, or down 4. If we go over 3, it should be 9, because 3 squared is 9, or down 3 if it's negative. 4 should be 16, because 4 times 4 is 16. So if it's going up, it's 16. If it's going down, it's negative 16. If you don't get those numbers, then it means you're looking at a fraction, or maybe the A value is a whole number like it was in, actually an integer, like it was in the orange graph, is negative 2. Alright, so in challenge 6 here, you're supposed to, or screen 6, you're supposed to use the vertex and then come up with an equation. So again, if I go over 2, the answer is supposed to go up 4, because 2 squared is 4, but it's only going up 2 of the 4. So what A value would make it go up 2 of the 4 if the 4 is supposed to be the answer if A is 1. So the vertex in this problem is at 4, negative 2, so it's going to be y is equal to, in parentheses, x minus my number squared plus my number. So the number is going to be 4 because the vertex is at 4 as the x value. And then the k value is at -2. So if I say check my work, you'll notice that the graph doesn't quite work because the a value is not 1. So if I go over 2 and 2 squared is 4, it should go right through that point, but it's being compressed. Basically, it's going up slower than it's supposed to, so it's up 2 out of 4. So that makes that the a value would be 2/4. Okay, I'm going, so because it's going up half as much, so or 1/2. In this problem here, it's asking you to adjust the equations to create the 3 parabolas so they actually do work. So we want to adjust to make sure that to create parabolas that go through the points. So the 2 points are at -4 and here at +3. So with the bottom one here, it's going through 2 and -2. And that's based on these factors here. So if I wanted to x plus 2, if I would stick in -2, that would make it a 0. That would be that point right there. And if I put a 2 in here for x here, you're going to get 2 minus 2, which makes the other 0. So that's going to be the 2, 0 here. So I want to go through 4 and 3, so or -4 and 3. So to get -4, that's going to be an addition problem. So it's going to be x plus 4. So if I stick in -4 here, it's going to give me a 0. -4 plus 4 is 0. And over here, I want this to be a 3. So it's going to be 3 minus 3 makes a 0. So that makes that equation y equals x plus 4 times the quantity of x minus 3. For the blue graph, we're going down twice as fast. And again, we want to go through those same points. So it's curious, if I would go ahead and replace the 2 with a 4, you notice that it actually goes through that point. And if I replace the -2 with a -3, it also works. So even though the graph has a different a value, to go through the 4, -4 and 3, the parentheses actually end up being the same. And then for the red graph, we wanted to go through, again, the 4 and the -3. So if I put in here, or the green graph, plus 4 again, and -3 again, you'll notice that the graphs will go through all the same points. So the key in working with what's called factored form, this is factored form, the key is that if I want graphs to go through the same 2 points, I got to make sure that the parentheses I'm using are the same parentheses. So this problem here, you're being asked to come up with the equations that would go through the graphs. Some of the graphs are going up, or also it's called concave up, and some of them are going down, which is called concave down. So I'm going to stop here, and if you've not completed this screen, go ahead and do that, and then you should return to the handout and finish page 3, which is on factored form. That factored form will look a lot like what we did here in problem on this screen here. This is an example of factored form. And then when you're done with that on that page, then come back to this activity and begin working on screen 9. You're doing 9 through 13.